Hi, my name is Jane Sullivan, and we are here at the Champaign-Urbana Mass Transit District. We provide the public transportation service here for Champaign, Urbana, Savoy community, the University of Illinois campus, Parkland College, and behind me is our administrative facility, and the parking lot I'm standing on is made of permeable pavers. This is the parking lot where most of our employees park, and these pavers were installed in 2010. The purpose of this project was to protect our groundwater and prevent water from pooling in the lot, and to really add to one of our many environmental sustainability efforts here. So we had an asphalt parking lot that needed to be replaced, and we were able to receive some grant funding in 2009, and so the parking lot was replaced with permeable pavers that help infiltrate water back into the groundwater system. It helps reduce runoff and erosion, and it has served really well for us. The maintenance costs are pretty low. We don't need any special tools or anything to maintain it. So it's held up pretty well 11 years later, I guess. And it's used pretty much all day, every day for parking. And so we're happy with the project, and we're happy to share it with others who are interested in these types of efforts. This is a project we're really proud of. We're happy to share it with the public, and I hope you all enjoy the tour.
So this parking lot serves several functions. One is obviously a parking lot providing structural support for vehicles and driving and heavy things. It also allows infiltration of water right here where the rain falls. That allows for lack of ice buildup in the winter and lack of ponding and things like that can cause problems on the impermeable surfaces. The other thing that it does is catches water from the adjacent areas and provides infiltration for those areas too. So it acts in a greater capacity than just this location. So when you build a permeable pavement system out of permeable pavers, the first thing you need to start with is excavating the ground. You want to make sure you have a stable, level surface, so you might do some compaction there, but very minimal because you still want the water to infiltrate through the ground. The next layer is an aggregate layer. You need to use at least 1.5 centimeter pieces of rock that are edged and sharp, so they can lock in together and create some large pores. On the top of that, you'll put a layer of choker, and we have some choker stone here. It's small and has not very many fines, but again, it can lock together nicely. Then you'll put your bricks. So these are some paver bricks that we have. These are not the ones that are here at MTD. The ones at MTD are L-shaped, and that creates a more stable surface and locks together better. So here you can see one of the L-shaped bricks, and you can see the raised areas that are giving you those void spaces. You can also see that the choker layer is missing from this brick and is not very high all through here too. So this piece needs to have additional choker. Well, first it needs to be vacuumed so you can get out the sediments and debris, and then you need to add additional choker layer so that it is even with the top of the bricks. But these are for demonstration, and you can see that they have raised areas right here. When you put the bricks together, they have void spaces in between. You fill that up with choker, and that allows the water to infiltrate through those void spaces. So to test the functionality of permeable pavement systems, you need to perform what we call an infiltration test. And in that, you put a designated amount of water in a certain area, and then you can calculate how fast the water moves through the pavement. You usually want to perform 3 tests in a 25,000 square foot area, and then average those numbers together, and that will give you your infiltration rate. If you do that periodically, you can see whether the functionality of your paving system is going down or staying the same. If it's going down, of course, then you want to do some general maintenance to make sure that the functionality improves. So what we've done here is put a PVC pipe with some plumber's putty along the inside and the outside rims. That will allow the water to stay in that particular area, and then we can calculate exactly the volume that goes through in a certain amount of time. So you definitely want a timer, and we are going to pour in a gallon of water, and then we can calculate that infiltration rate. So this parking lot was built in 2009 and has had very little maintenance in terms of vacuuming or replacing any of the choker layer in between the permeable pavers. So here you see that there is an excess of sediments. You can't see any of the choker layer right here, it's just dirt. And here are some plants that are actually growing in those crevices. So you don't want these things here. This could be removed by pulling or using herbicides. This also has to really be vacuumed out, or you can use a high pressure sprayer to remove those things. You do have to be careful that you're not removing all the choker layer. However, at this point in this parking lot, probably a high pressure sprayer is the best option to clean it out. You would then have to replace the choker that you remove with clean choker, and again add that up to the surface. But you can see that it still works. However, this is a lot longer of an infiltration time than would be at prime functionality. So this is an impaired parking lot. It should be something like 12 seconds for all of that water to go down into the ground, but it was taking quite a bit longer. So now we're here and we're going to do our second infiltration test, and I'm just going to pour a gallon of water into the same container. Well, thanks for joining us here at the MTD Administration Buildings in Urbana, Illinois, and we hope that you see some lessons learned from a lack of maintenance, but also how green infrastructure and permeable pavement can help to improve water infiltration in a built environment.